Hello, everyone. Today I want to talk to you about science and to show you a really cool science demonstration that you can try at your house. Before we do that, I want to go over the scientific method with you to remember and to practice what are the steps that all scientists have to use. Right? What does a scientist do, right, when we're learning about the world around us? So first of all, before we get to our demonstration, let's take a look at this. So the first step for a scientist is to ask a question. Right? Why does this happen? Who, what, when, where, or why? Sentences that start with those words. Who did this? What is this? Why is this? How is this? Where is this? When did this happen? Things like that. Lots of questions. That's the first step to all science. Number 2, make an observation. Look around the world around you, or listen, or smell, or see, or touch, and try to see what is this thing around me that I see? What can I see about? If you're trying to learn about clouds, what do they look like? You're trying to figure out what this table's made out of? Knock on it. Make an observation means try to see what it is. Number 3, make a hypothesis. That means come up with your guess. I think this table might be made out of pretzels. It might be made out of pretzels. That is a hypothesis. Now, it doesn't matter if you're right or wrong. This table is definitely not made out of pretzels. That hypothesis is wrong, but that is okay. You make your hypothesis. Later, you will conduct an experiment. That means you will test your hypothesis. You're going to decide, is this made out of pretzels? Well, maybe I could try and break a piece off like I could with the pretzels. Pretzels are very crunchy. I could break a piece. I can't really break a piece of this table. So maybe it's not made out of pretzels. Conduct an experiment. That means test your hypothesis. After that, you need to analyze your data. That means think about your experiment. What did you learn from your experiment? Well, I learned that I can't break this table, but I also got some pretzels and I broke those. And so I know I can break pretzels, but I can't break this table. That's some information that I learned from my experiment that I can think about. All right, the next step is to draw a conclusion. That means think about your hypothesis. Was I right or was I wrong? Remember, it doesn't matter. If you are right or wrong, it doesn't matter because either way, you learned something. I learned I was right or I learned I was wrong. It doesn't matter. Either one of those, you learned something new. That's the important thing. And the last step, very important, report your results. That means share the things that you learned with other people. Maybe they have the same question that you have. Maybe other people want to know what this table is made out of, right? Or maybe somebody else thought this table was made out of pretzels. And if you share your results, you can help them learn too. So reporting your results is very important. That is the last step of the scientific method. All right, now, I've got a problem. I want to drink this apple cider, but it's not cold. And I really like it when it's cold. Now, I could pour it in a glass and I could put some ice in it, but then there would be ice inside the apple cider and it might the ice will melt and then the apple cider won't taste as good. So I don't want to do that. I could put it in the refrigerator, but that's going to take a long time, a very long time. I could put it in the freezer, but that's going to take a long time too to make this cold. And if I forget about this can in the freezer, it might explode and make a big mess. So I don't want to do that. Well, today I'm going to teach you a trick. And all you need is some sort of a bucket or a bowl. You need some ice, like this, and you need some salt. I've got a bag here of some salt. You're going to pour some salt in. I already poured some salt in here. But you're going to pour some salt in like this. And then you're going to pour a bunch of salt in. I poured a lot of salt in here earlier. Then you're going to mix that salt up with your fingers. You can feel when the salt mixes with this ice water, it becomes very, very cold. And that's the special trick that's going to help us make this drink colder faster than the refrigerator or faster than the freezer. All right, so let this sit in our bath. And while we're doing that, we're going to look at a demonstration. And by the time we're finished, I think our drink should probably be cold. Let me move this out of the way. Remember, at home, all you need is that salt, the water, and the ice, and your can of something to drink, like apple juice. Now, for this demonstration of how this works, how is this ice and water going to make our can cold? We need two things. We need 2 trays with just some ice cubes on it, and we need some salt, and we need some string. Okay. All right, so if I try to go fishing for ice by using this string, so on this side, I'm going to stick this on here, and I try and pick up some ice. I'm going to try and catch it like I'm catching fish. But it's not working. No matter what, if I push it on there, if I push it on here like this, there we go. Is that working? No. It's not working. Sometimes it helps. Maybe I should get the string wet. Let's check. Oh, I can't catch anything today. Unlucky. And on this side, I'm going to do the same experiment. I'm going to get my string a little bit wet, same as before. And I'm going to put it on top of this ice. But the other thing I'm going to do is I am going to add some salt. Let me stick this on here. These ice cubes are slippery. There we go. Let me put a sprinkle of salt down on this. There we go. Let me make sure it's down there. All right, put a sprinkle of salt on there. Dry off my fingers. Now, on this side, when I was trying to catch my ice, I can leave that on there. I can push it on there, but nothing happens, right? I can't catch it. But this side, when I put the salt on there, we can see it's starting to stick. See, I can pull this ice cube around. Now, it's not quite solid on there yet. If I press it on there, I think I can get it to melt all the way. But you can see already I can pull around. But on this side, I can't pull anything. When I pull the string, it just slides around. But here, I can pull this ice cube all around the tray. Look at that. How is this working? This side, nothing. Even if I press really, really hard, nothing. But this side, it's sticking to this ice cube. I can try and grab another one too. Let's put a little bit more salt on this cube right here. Let's press it down on there. Make sure it gets on there nicely. There's a little bit of water too. This side, just to show you there's no tricks, put a little bit of water here. Press down really hard. Get ready and... nothing. But over here, let's see if we've got 2 ice cubes now. Oh, look at this. Now I've got 2 ice cubes. Now I can almost just about... look at that. I caught 2 ice cubes. But this side, it just doesn't work. No matter how long I leave these on here, it just doesn't work. Think we can catch another ice cube? Let's give it a try. You can do this experiment at your house. All you need is a plate, some ice, and some salt. So here I go. I laid this string on top. Let's get the string wet. I think it works best if the string is a little bit wet. All right. Then I sprinkle some salt on top. Let's see. And already I can start to pull this around. Already I can start to pull this around. Look at that. There it goes. Now let's see if I can pick it up. But the second one fell off. But the third one's still going strong. There we go. So what's happening here? How can I catch an ice cube on this side, but I can't catch an ice cube on this side? Well, the only thing that's different is the salt, right? Both of these are plates. Both of these strings are the same. The plates are the same. The ice cubes are the same. The only difference is that this side has salt and this side doesn't. So what is happening? Well, let me explain. When you sprinkle salt on ice, it does something really special to that water, the water that's in the ice cube. What it does is it changes the temperature that the liquid water can change into solid water. So it changes the temperature that the liquid water changes into ice. Okay, so what it does, when I sprinkle the salt on there, the ice starts to melt. Now the temperature is the same. This salt is not warm. It doesn't make the ice warm, but it starts to melt the ice. Because even though the temperature is the same, it changes the freezing temperature of the ice. So even though this ice cube is the same exact temperature, all of a sudden it is melting because of the salt. The salt is changing the temperature that it becomes a solid. But here's what happens. When I sprinkle the salt on the top, it starts to melt the ice right in the middle, right like this. You can kind of see it if it starts to kind of like, if you hold it up and look at it, you can see it kind of like eats away and makes a sort of a bowl shape in the top like that. But as it melts more and more water, the water from the ice cube starts to mix with the salty water and the salt, and there's less and less salt because there's more and more water melting. And when there's less and less salt, what happens is suddenly the ice cube can freeze again because now there's not enough salt. Before, when I added salt, the ice could change back into a liquid, even though it was cold. But once I take away, or once the ice starts to melt and that liquid, that water from the ice cube mixes with the salt, now all of a sudden it's not very salty anymore because there's a lot more water. And what happens is it changes back to a solid. So that means the string can freeze back onto this ice cube. The ice cube can freeze around the string. So salt can change the temperature that water freezes. So here's my question to you. Right? We just saw this experiment. We just saw the difference between no salt and salt, right? And I told you that the salt in this water, the salt that's in this water, can help this drink get colder faster. Here's my question to you. Which do you think would freeze first? If you took 2 cups and you took one, you put them in the freezer, and you had 1 cup of salty water and 1 cup of regular water, which cup do you think would freeze first in the freezer? This is another easy experiment you can do. Make sure you don't fill your cups up too high or they'll spill out everywhere. And make sure they don't have a lid because they might pop. But which cup do you think will freeze first? The regular water or the salty water? If you said the regular water, then you're correct. Because the more salt you put in, the more melty the ice got, right? When I put salt on, what happened to the ice cube? It started to melt. It didn't freeze. But this one stayed frozen, right? That's why the string couldn't go on top, because it didn't melt at all. So there was no change. It couldn't melt and then freeze. But this one first melts and then freezes, right? If I melt another piece on, let's sprinkle a little bit more salt and see let's find another ice cube. I like this big one right here. Let's lay this string right on the top, sprinkle it. Now remember, this salt is not warm. It's not warming up the ice cube. The ice cube is the same temperature, but it is melting the ice cube. It's changing the temperature. If you have a lot of salt in water, the temperature that water freezes actually goes down. Usually water freezes around 0 degrees. That's when, if it was 0 degrees outside, it might start snowing, maybe. Usually water freezes at 0 degrees. When you start putting a lot of salt in, the water can actually go less than 0 and still stay a liquid. That's called supercooled. It's supercooled. So what we're doing here with our let's see if this worked first. There we go. Ooh, we caught a good one. That's a big ice cube that we caught. That's pretty fun. But again, over here, nothing at all. Now, going back to our demonstration, I told you that when we add salt to water, we can make a super cooled liquid. Super cooled means super cold, right? But not frozen. We don't want it to freeze. So in here, this water is so cold. I think you're going to enjoy doing this experiment at home, because when you stick your fingers in this salty ice water, oh man, it is so cold. It is so cold. That would be another fun experiment. If you have a thermometer at your house, set up one bowl with regular water and ice in it, and set up one bowl with ice and salt and water, and put a thermometer in both of them and see the difference, right? We know this one's colder. Well, I told you that this one's colder. The salty water would be colder, but how much colder? That's another experiment that you can do at your house if you have a thermometer. Oh boy, this is so cold. Let me take this drink out. It's only been sitting in here for a few minutes, right? Just during our video and just while we were doing our demonstration. Now, I can't tell if it's cold yet with this hand, because this hand was just in the cold water. But I'm going to turn it over and I'm going to give it to this hand. This hand is nice and warm. And let's see. Oh, this is definitely starting to get cold. I could drink this just like this right now. If I dried this off, I could drink it right now. It's already much colder, much colder than if I had put it in the refrigerator. much colder. So I think there's a lot of experiments that you can do here at your house with just some salt and some water and some ice. You can put one can in the refrigerator and one can in our super cooler and see which one cools down faster. You can put thermometers in it. You can test, maybe put your drink in for 10 minutes in the super cooled liquid and 10 minutes in the refrigerator, and use a thermometer and check the temperature. What are the temperatures? What's the temperature from the refrigerator? What's the temperature from the super cooled liquid, right? You can do our demonstration with salt and ice to go fishing for ice cubes. And you can just have some fun. It's really fun to stick your fingers in this liquid because it is so cold. It's really surprising how cold it is. You know that ice is cold, of course. And you know what cold water feels like. But when you start making salty, super cooled ice water, then you really know what cold feels like. All right, well, I hope that you learned a new trick for how you can make your drinks nice and cold and ready for the drink, even if you only have a few minutes. And it works best with cans. A PET bottle, like a plastic bottle, will work too, but I think cans work the best because the metal is good at transferring the cold into the drink. So it works best with a can, but I think a PET bottle will work, or a glass bottle will work also. So we learned a special trick to make our drinks cold quickly. We learned a demonstration that shows us why that happens, how it happens, with the salt lowering the temperature of the ice, or lowering the temperature of the liquid before it freezes, right? We saw that once it starts to melt, then more and more water mixes with the salty water, and then it gets cold again. And it goes, oh, now I can freeze again. And then it freezes and the string gets frozen right on top. And we saw that our plate that had no salt, we couldn't catch those ice cubes at all. No matter what we try. We press hard, we let it sit for a long time, but nothing at all. That doesn't work at all. So, all right, I hope you have fun with this experiment at home. It's so simple, just salt, ice, and water. That's it. Any salt will work, any water will work, and any ice will work. But another thing you can do, technically, the cleaner the water, the easier this will work. Now, a lot of the water that we drink has special minerals in it that are good for our body and that make the water taste nice. But the cleaner your water can be, like if you get distilled water, which is a special super clean water, the cleaner that your water is, the colder that it can get. So, and not just clean, I don't mean clean like dirty, but the more minerals that are in your water, like for example, calcium or magnesium. Those are things that come from the ground that our bodies need, that are oftentimes in bottles of water. The more of that stuff, the less cold your water will be. So you can do an experiment like that too. You could buy one bottle of super clean, purified water and one bottle of just normal drinking water and mix it, and you can check with a thermometer and do that experiment too. There's so many different experiments you can do with just these simple ingredients: salt, water, and ice. All right, I hope you have a lot of fun doing science at home with salt and water and ice. Don't forget to ask a lot of questions. Ask your parents questions, ask your friends questions, ask your teacher questions, and keep going. Keep asking questions every day until they're like, you're asking me too many questions. And you say, of course I am. I'm a scientist. All right, I hope you enjoyed this video, and I can't wait to hear about your experiment at home. Have a good night. Talk to you later. Bye-bye.